start the design process. So you probably should have a new Google Doc started, as it was said to you in the instructions, so that you can take notes on this. You'll be able to use those on the quiz at the end of this unit, and without it you probably won't pass, so make sure you take notes throughout. So first off, what is design? Design is often used as a generic term. It refers to anything made by human effort. Design, anything made by human effort. It is a process used to solve problems. So those would be a couple things that you probably want to note. And so we're going to look at the design process based off Project Lead the Way. So here is kind of the overview, and you've, I know, worked in many different classes, at least in engineering classes, maybe just one last year or a couple in the last couple years that have talked through the design process. Here it is all together. We're going to look at each one of these. So number one is define a problem. So what I would suggest you do is just note each one of them, and then maybe just a really brief note as to what each one of them is. So in your transfer system, you're asked to solve a problem. How can we move something from point A to point B with multiple stops throughout the way? That is the receiving a problem. You gathered the information you needed, how many stops it had to have, and then it says be inspired through media exposure of a current problem and take action. So maybe you would look at what else is happening out there, what other problems exist that you can compare it to. Then you're going to brainstorm. You have to brainstorm ideas for your transfer system. You would present ideas in an open forum. Your team decided, what do we want to do? We generated ideas, you kind of record ideas. How do we want to make this as cheap as possible to get from point A to point B? Then it says keep the mind alert through rapidly paced sessions. You want to just boom, 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 get as many ideas as you can, and then develop any preliminary ideas. Number three, research and generate ideas. And remember, you can pause this at any time and go back so you can take your notes. In the cost analysis activity, that was the transfer systems, you had to analyze your solution and compile data to see how things could be improved. How can we reduce the number of parts we use? One way you could research is to conduct interviews with people affected. Obviously, you didn't have to do this with this last project. Research solutions that already exist and find out why they're not appropriate for the current situation. Why can't we already use something that's already out there? Compile ideas and then report your findings to the team. Number four, identify criteria and specify constraints. You identified problem areas, which is cost of labor, the cost of all the materials in the transfer system, and you got to figure out how we're going to move forward with this. So you probably didn't write all these criteria down, but you were thinking about them. So this says identify what the solution should do and the degree to which the solution should be pursued. Identify the constraints. So yours were cost of labor and cost of materials, and then draft a design brief. So the larger the project, the more detailed each one of these steps are going to have to be. Plexus Engineering Corporation in Louisville, they go through all this process. It's a company that takes an idea that somebody gives them, and they have to go through these steps, and they may have a $4 million budget. And so if someone is giving them $4 million to take their idea and actually make a prototype, they are going to want to see, okay, everything kind of written out so they know that Plexus is doing their job and coming up with a good solution. Number five, explore possibilities. You probably made changes and came up with different ideas as you were going through. You realized, the conveyor belt didn't allow room for the piece to go through, so you had to widen things. So this says consider further development and brainstorming ideas with constraints and trade-offs, and then explore alternate ideas based on further knowledge and technologies. And number six, select an approach. Review brainstormed information and answer any lingering questions. Narrow ideas down through a voting process or by use of a decision matrix, and then decide on a final idea, usually through group consensus. Generally, it's through a decision matrix, and we didn't really get into that with this. Won't really get into that much with this course. Definitely a big part of senior design is using a decision matrix. And just part of engineering in general. For the project that we've had that went to the space station, the NASA engineers talked about decision matrices all the time. So you probably just kind of decided and discussed as a team, let's do it this way, let's do it this way. That doesn't always work in a large project. You have to say, we're going to do it this way because it makes these things better. So that's why it's a better approach. Number seven, develop a design proposal. Explore the idea in greater detail with annotated sketches. Make critical decisions such as material types and manufacturing methods, generate through computer models detailed sketches to further refine the idea, and produce working drawings so it can be built. So the one thing I asked you to do first was actually sketch it out, show me, who's kind of like the client, and say, hey, is this going to work? Is this what you want? And then I would say, no, we need to stop here, move those sensors over. We don't need to have 2 motors. I don't want to pay for 2 motors. 1 will do. So those kind of things would work. Now, if you're actually working on a big project, you're going to have things computer modeled. Why would that be? Because you're putting $4 million into a product, or $2 million, or $500,000, or $20 million, whatever it is, big numbers. Things need to be modeled, because modeling it on 3D software is really cheap, but to actually manufacture it is incredibly expensive. So everything needs to be modeled first to make sure it's going to work, and planned out first, because you're paying engineers, hundreds of dollars an hour, perhaps, or $100 an hour. And if they're just kind of tinkering and just trying trial and error to get it to work, that's a lot of wasted money. Whereas coming up with one design, and you can identify what problems are along the way, can save a lot of time and resources later on. The larger the project, the more pre-planning. Then you make a model or a prototype. You can make models to help communicate the idea or study aspects, such as shape, form, fit, or texture, and construct a prototype from the working drawings so the solution can be tested. So your VEX model was generally kind of like a prototype. It wasn't really a finished thing because it wasn't part of a larger system. So that first thing that you made was really most like a prototype. Then we test and evaluate the design using specs. The design experiments and test the prototype in controlled and working environments. You test it out first in a lab, a controlled environment, make sure it works there. Then you test it out in the field where it's supposed to be working, and see if there's any other conditions you didn't consider. Gather performance data, analyze and check the results against established criteria, and then conduct a formal critique to flesh out areas of concerns, identify shortcomings, and establish any need for redesign. So when you completed the transfer system, you probably found problems, the blocks fell off, took too much time to add parts, the conveyor belt was moving before you wanted it to, so you had to modify it to make it work better or make it work faster. Then it comes to refining the design. You make any design changes, rebuilding it, make refinements until accuracy and repeatability of the prototype's performance results are consistent, maybe to the point of 6 sigma, that 3.4 defects out of 1,000,000. You're that good. Update documentation to reflect the changes, and then receive users' critique to provide outside perspective to help determine if established criteria have been met. That would mean the person who's paying you the $4 million for the product, you give it to them. You say, hey, does this do exactly what it is that you wanted? And so then let them test it out just to make sure, because they might see things a little bit differently. So with the refine, you probably refined it numerous times through the coding and as you were starting to practice assembly. And then you're going to create or make a solution. So you determine mass production or packaging. We didn't get to this step in the transfer system with VEX because we just made our one prototype. So custom production is making a small number, just 1 or 2 different things for a client. Mass production might be used on a wide scale if you're doing like fuse deposition, or not fuse deposition, but injection molding. You're making lots of plastic parts, so you're mass producing things. We didn't do that, obviously. And then 12, the last one, is communicate processes and results. You would communicate the designer's final solution, such as a PowerPoint, post-session technical report, market the product, and then distribute it. So you're going to communicate it to the client, say, here's everything that we did, here it's finally done. Then they can take that and use that part of the presentation to maybe market what they're trying to sell. They can say, here's what we've done to make this, here's why it works, and this is why you should buy our product or put it on your shelves or whatever. In your transfer system, you made a presentation, and it was pretty much just posting everything in there just to describe your process. So it was just kind of a demonstration. So for a research project that you do, you might have to write a paper. In the manufacturing process activity, when you do the history of manufacturing, you give an oral report. So communication can come in lots of different forms.
So they can be prioritized and used as part of a corporate risk reduction process. These potential failures can be part of the physical product or the processes used to engineer and manufacture it. The risk management focus at Bosch has one goal: defect-free products. Companies do an FMEA because all potential risks involved in designing, testing, and manufacturing products can be managed with this disciplined approach to engineering documentation before the product is produced. The FMEA can quickly direct engineering toward the highest ranked potential risks early in the design process.